This video is on the Pythagorean Theorem. The Pythagorean states that any triangle that has a right angle is called a right triangle. The two sides that form the right angle, A and B, are called legs, and the side opposite that is across the triangle from the right angle of, or C, is called the hypotenuse. So the Pythagorean theorem states that for any right triangle, the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse. That means that a squared plus b squared equals c squared. This relationship is known as the Pythagorean theorem. So in words, the theorem states that leg squared plus leg squared equals hypotenuse squared. The reason we want to know this in words, the leg squared plus leg squared equals the hypotenuse squared, is mainly because if you're labeled your triangle as anything other than A, B, and C, it can get kind of confusing. Also, if your legs are labeled with the C and the A and your hypotenuse is a B, then that means that you would be thinking A, B, and C, and your C is your hypotenuse. You have to be careful about what your triangle is labeled as. So you have to know what your two legs are and then which one is represented by your hypotenuse. So some examples for here. We're going to draw a diagram, then use the Pythagorean theorem to write an equation to solve each problem. Now sometimes the diagram is already given to us. Part A says solve for the missing side. We do have a right triangle, so we want to use our leg squared plus leg squared equals hypotenuse squared. Now in this case, our leg is a 13, our leg is a C, and our hypotenuse is 17. The reason we know the hypotenuse is 17 is because it's across from or opposite the right angle. This is our hypotenuse. You should always find your hypotenuse first, so you know which one you're dealing with. So on here, our leg is 13, so we're going to have 13, then we're going to square it, plus our other leg is C, so we're going to have C squared is equal to our hypotenuse squared. Our hypotenuse is 17, we're going to square it. So 13 squared is 169, plus C squared is equal to, so 17 squared is 289. We're going to subtract the 169 so we can get C squared by itself. So we'll end up with C squared equals 120. It says solve for the missing side. So we're going to take the square root of both sides. So our leg, the square root of 120 is roughly 10 and 95 hundredths. So C is approximately, if we just go to the nearest whole number, would be 11. So again, on our calculator, if I use my calculator, square root of 120 is 10 and 95 hundredths. So if I just round it, even if I just round to the nearest tenth, it would be 5 makes that 9 go up. So this 99 would go up to a whole number, which would be an 11. B, find x to the nearest tenth. So we will actually have to the nearest tenth. We do have a right triangle, so we want to find our hypotenuse, which is opposite of the right angle. This 20 is our hypotenuse. So we start with our legs. Our first leg is, it doesn't matter which leg you start with, so let's say our first leg is 5x. We're going to have 5x is our first leg. We have to square that entire thing. Plus our second leg is x. We have to square it. Is equal to our hypotenuse squared. So that's 20, and then we're going to square it. So 5x, all of that squared actually turns into 25x squared, because you have to do 5x times 5x. Plus x squared is equal to 20 squared is 400. So if we want to combine our like terms, 25x squared plus x squared is actually 26x squared is equal to 400. Because that's 25x squared plus 1x squared, we're combining our like terms. We divide by that 26. So we have x squared is equal to 15 and 4/10. 400 divided by 26 is 15 and roughly 4/10. So we're going to round to the nearest tenth. So in order to do this, we now take the square root of that 15 4/10. So we'll take the square root of 15 4/10, which is roughly 3 9/10. We'll round to the nearest tenth. So x is approximately 3 9/10. Example C. One end of a 10-foot ladder is 4 feet from the base of a wall. How high on the wall does the top of the ladder reach or touch? So our ladder is 10 feet, so we can actually label our ladder with the 10. So we don't have everything labeled. You have to make sure you label it all. And it says it's 4 feet from the base of the wall. The 4 is down here. The base of your ladder is 4 feet from the base of the wall. So that's where that 4 comes from here. The question is, how high on the wall does the top of the ladder touch? So we want to know from the bottom to the top. This is our x. So this does form a right triangle because we do have a vertical wall and a horizontal ground. So our right triangle, the hypotenuse on our right triangle is that 10. So I'm going to highlight that. So our leg, our first leg could be our 4 squared plus our second leg is that x squared is equal to our hypotenuse squared. 4 squared is 16. So we have 16 plus x squared is equal to 100. We want to subtract the 16 from both sides. So we end up with x squared is equal to 84. So if we round this to the nearest tenth, we're going to take the square root of 84. Square root of 84. And it is 9 and roughly 2/10, so 9 2/10. So it reaches up the wall 9 2/10 feet. So x is approximately 9 2/10 feet because we do have units here. And if we think about that, the ladder can only reach up to 10 feet only if it's standing up straight. So this one is tilted against the wall, so it is shorter than that 10 feet. So that makes sense of why it is shorter than 10 feet. Okay. Question D says, could 3, 6, and 8 represent the lengths of the sides of a right triangle? And explain. Whenever it's asking if it can make the lengths of the right triangle, we have to determine if it can even form a triangle. So you always ask yourself the question, can it make a triangle? If we go back to the triangle inequality theorem, it states that the 2 smaller legs have to add up to be bigger than the third for it to even be a triangle. So we have to see if 3 plus 6 is greater than 8. 3 plus 6 is 9, so 9 is greater than 8. So that does work. So it is a triangle. So now we can do the Pythagorean theorem to determine how they are related to it. So we ask ourselves, is it going to be a right triangle? We take our 2 smaller legs, so our 3 squared plus our 6 squared, and we figure out what is it connected to with regards to that 8 squared. 3 squared plus 6 squared is going to be 45, because that's really 9 plus 36. 45 is what to 8 squared is 64. So it's all with regards to the c squared. C squared is actually bigger. That means that this is not a right triangle. This is not a right triangle. Because in order for it to be a right triangle, it has to be equal to. But c squared is actually bigger, so that means it's actually an obtuse triangle. So I'm going to put that in brackets here. This is actually an obtuse triangle. A right triangle states that a squared plus b squared is equal to c squared. That your 2 legs are equal to your hypotenuse. So here's some extra problems we're going to work on. Solve the following problems. So number 1, a 12-foot ladder is 6 feet from the wall. How high on the wall does the ladder reach? So this one, you would want to draw a diagram for it. We know it's a 12-foot ladder is 6 feet from the wall. How high on the wall does the ladder reach? The ladder is going to be leaning against that wall. So we have a wall and we have a ground. Therefore, we have the ladder leaning against the wall. This does form a right triangle. We have our 12-foot ladder. 12-foot ladder is 6 feet from the wall, so that 6 feet goes on the bottom. And so it says, how high on the wall does the ladder reach? So we're looking for this x right here on the wall. Our hypotenuse is opposite that right angle, so that's that 12. So we would have our leg, 6 squared, plus our other leg, which was our x squared, is equal to our hypotenuse, which is 12 squared. So again, we have 6 squared is 36, plus x squared is equal to 144. So we'll end up having x squared. If we subtract the 36, x squared is equal to 108. So to the nearest tenth, if we take the square root of 108, we have x is approximately 10 4/10 feet on the wall. That's how far up the ladder reaches. 10 4/10 feet on the wall. Number 2, a 6-foot ladder is 1.5 feet from the wall. How high on the wall does the ladder touch? So again, we're doing the same setup. Let's draw a picture of that. So we have a wall, we have a ground, we have the ladder. The ladder is 6 feet, so that's where that 6 goes. 1.5 feet from the wall, so this is going to be 1 5/10 or 1.5. I'm going to use the decimal down here. How high on the wall does the ladder touch? This is our x. So again, our hypotenuse. So we have our first leg is 1.5, so 1.5 squared. Our second leg is x, or square it. It's equal to our hypotenuse squared, so we have 6 squared. So 1.5 squared is actually 2 25/100. 2 25/100 plus x squared is equal to 6 squared is 36. So if we subtract the 2 25/100, we'll have x squared is equal to 33 75/100. If we take the square root of that, the ladder will reach up to approximately 5 8/10 feet. X is approximately 5 8/10 feet up on the wall. And it does have to be smaller than the 6 feet, so that does make sense. So that's 5 8/10 feet. Question 4 says 5, 12, and 13 represents the length sides of a right triangle. Could they? Justify your answer. So again, the first thing you have to do is, can they even form a triangle? Can they even form a triangle? So we do 5 plus 12 has to be greater than 13. 5 plus 12 is in fact greater than 13, so it is a triangle. Now we can determine if it's a right triangle or not. To determine if it's a right triangle, a squared plus b squared has to be equal to c squared. So we have our two smaller lengths are your a and b. So 5 squared plus 12 squared has to be equal to 13 squared. That's our question. 5 squared plus 12 squared, so that's 25 and 144. That's equal to 169. 13 squared is 169. 169 is equal to 169, therefore this is in fact a right triangle. This is a right triangle. Actually this is question 3 down here. Could 2, 3, and 6 represent the lengths of the sides of a right triangle? Justify your answer. So first we've got to see if it can be a triangle. So we do the two smaller legs have to be bigger than the third. So 2 plus 3 has got to be bigger than 6. This is 5. 5 is not bigger than 6, so this is not even a triangle. So we can't even say what type of triangle it is because it's not a triangle. So we stop there. Not a triangle. We always look back to see if it is a triangle at all. This last question says, could 10, 15, and 20 represent the lengths of the sides of a right triangle? So again, we look to see, is it a triangle? Two smaller are 10 and 15, so 10 plus 15 has to be greater than 20. 10 plus 15 is 25. That is bigger than 20, so it is a triangle. Now we have to determine if it's a right triangle. So two smaller legs, we have 10 squared plus 15 squared is supposed to be equal to 20 squared. That's our question. 10 squared plus 15 squared, that's 100 plus 225, is 325. Is that equal to 20 squared is 400? These numbers are not equal, therefore this is not a right triangle. This is no, so not a right triangle. But what kind of triangle is it, since it is a triangle? It's related to that c squared, so c squared is actually bigger than the others. So this part's bigger, therefore that means that this is an obtuse triangle. This is an obtuse triangle. That's Pythagorean theorem.